Hello everyone, welcome back to more Math 2413. We're going to do Chapter 2, Section 1 homework today. Alright, so let's look at them. Here's our first one. It says, find the average rate of change of a function over the given intervals. So the first one we have, for number 1, is Chapter 2, Section 1, Question 1. So the function is f of x equals 7x cubed plus 7. We're going to look at two intervals. Our first interval is at 6 to 8. Remember, the average rate of change, which I'm going to call from now on arc, is simply the vertical change over the horizontal change. So change of y over change of x. And change of y is the function at the second point minus the function at the first point, divided by the second x value minus the first x value. It's actually the same thing as slope. This is what we called the difference quotient in algebra. Alright, so let's look at this. Let's do this problem. What we have to do, so this is x1, this is x2. We have to find f of x1 and f of x2. So we have to find f of 6 and f of 8. Go back to that function. So 7, here's the x, so it's 6 cubed plus 7. 6 cubed is 36 times 6 is 216 plus 7. 216 times 7, 42, 11, 14. Is 1512 plus 7 equals 1519. f of x2 is 7 times 8 cubed plus 7. So 8 cubed, 64 times 8. 512 plus 7. So 7 times 512. 3,584 plus 7 equals 3,591. So this is f of x2 and this is f of x1. So the average rate of change is f of x2, which is 3591, minus f of x1, which is 1519, over x2. x2 is 8 minus x1 is 6. $3,591 minus 1,519 is 2072. 8 minus 6 is 2. So 2 goes into 20 10 times. 2 goes into 7 3 times with 1 left over. 2 goes into 12 6 times. So the average rate of change is 6. $13.06. So that actually goes here. 13.06. We do the same thing for the next one. We use the same function, but this time we're doing the interval -1 to 1. So our function is 7x cubed plus 7 on the interval -1 to 1. So remember, this is x1, this is x2. So we have to find f of x1, 7x1 cubed plus 7, and then f of x2 equals 7 times x2 cubed plus 7. So at -1, -1 cubed plus 7. So -1 cubed is -1. Seven times -1 is -7 plus 7 equals 0. So f at -1, or f at x1 is 0. F of x2 is f at 1, 7 times 1 cubed plus 7. 1 cubed is 1. 7 times 1 is 7, plus 7 is 14. So that's f of x2, which is f of 1. So the average rate of change, or it's f of x2 minus f of x1 over x2 minus x1. So f of x2 is 14, f of x1 is 0, x2 was 1 minus x1, which is -1. The two negatives become a positive, so we have 14 divided by 2 is 7. So that's the average rate of change. So the average rate of change is 7. All right. That's the first one. Okay, now the second one, question number 2, is asking, let me get most of this stuff out. All right, what it's asking is this: find the average rate of change. So to chapter 1 and number 2. The average rate of change, remember, is f of x2 minus f of x1 over x2 minus x1. the function is cotangent t. And the first interval is at 3 pi over 4 to 5 pi over 4. So this is my x1, this is my x2. We'll do the same thing we did earlier. So the average rate of change, we have to find f of x1, which is f of 3 pi over 4, which is the cotangent of 3 pi over 4. Now I have, where I put this charts. Where did I put those charts? Oh, they're there. There. And you'll have this also on your email. So, cotangent is cosine of 3 pi over 4 over sine. Cosine over sine is cotangent. In trigonometry, remember that cosine and sine. Cosine deals with the x-axis, sine deals with the y-axis. So this is the cosine, and this is the sine. Easy way to remember that is x comes before y, c comes before s. So that's the easiest way to remember that. Alright, so looking at this. 3 pi over 4. So from 0 to pi, if we divide it into fourths, 1, 2, so 3 pi over 4. The cosine is negative square root of 2 over 2, and the sine at 3 pi over 4 is square root of 2 over 2. So the cosine, that's the x value, is the negative square root of 2 over 2. And the sine is the y value, is a positive square root of 2 over 2. Take the top, leave it alone. Flip the bottom and multiply. Positive, or negative times positive is negative. The square root 2's cancel, the 2's cancel, so it equals 1. So our f of x1 is 3 pi over 4. That equals negative 1. Do the same thing for f of x2. That's f of 5 pi over 4. Which is, okay, we want it of the cotangent, 5 pi over 4. Cotangent is cosine over sine. So we find 5 pi over 4. The cosine's negative square root of 2 over 2, and the sine is negative square root of 2 over 2. So it's negative square root of 2 over 2, negative square root of 2 over 2. The negatives cancel. It's the same number top and bottom, so it equals 1. Alright, so the rate of change is f of x2 minus f of x1 over x2 minus x1. F of x2 is 1. minus f of x1 is negative 1. x2 is 5 pi over 4 minus x1 is 3 pi over 4. So that becomes a plus. 1 plus 1 is 2. 5 pi minus 3 pi over 4. 5 minus 3 is 2. 2 goes into 4 twice. So it's a compact fraction. So take the top fraction, which is 2 over 1, multiply by the flip of the bottom, 2 over pi. 2 times nothing cancels, so it's 2 times 2 is 4. 1 times pi is pi. So the answer, the average rate of change of that function is 4 over pi. Do the same thing for the second one. We're from pi over 3 to pi over 2. The function is the same. It's the cotangent of t in the interval pi over 3 to pi over 2. So first thing we need to do is find, this is x1, this is x2. So f of x1 is f at pi over 3. The function is cotangent, so it's cotangent pi over 3, which is again cosine pi over 3 over sine pi over 3. We look at this chart, pi over 3, the cosine is 1/2. So the top is 1/2. The cosine's 1/2. And the sine value at pi over 3 is radical 3 over 2. Simplify that. Take the top fraction, multiply by the flip of the bottom, reduce, 2's cancel, remember you can't have radicals on the bottom, so you have radical 3 over radical 3. Radical 3 times radical 3 is radical 3 squared, which is just 3. So f of x1 is radical 3 over 3. Do the same thing with f of x2. F of pi over 2. The cotangent of pi over 2 is cosine pi over 2 sine pi over 2. Remember, pi over 2 is 90 degrees. The cosine is 0. The sine is 1. So that's 0. F of x2 is 0 over 1, which is 0. So that becomes 0. That becomes 1. So the average rate of change here f of x2 minus f of x1, x2 minus x1, f of x2 is 0 minus radical 3 over 3. x2 is pi over 2, pi over 3. But we had a common denominator, so multiply this one by 3, this one by 2, and it's over. So we have 3 pi over 6 minus 2 pi over 6, negative radical 3 over 3, negative radical 3 over 3. They're both the same, so 3 minus 2 is pi over 6. Negative radical 3 over 3. Flip the bottom, so you have 6 over pi. 3 goes into 6 twice. So the answer is negative 2 radical 3 over pi. And that's your answer for B. Negative 2 radical 3 over pi. Alright, so go number 3. Find the slope of the curve x squared minus 4x minus 4 at the point 3, negative 7. Now this is a point. This is not an interval. It's a point. By finding the limit of the secant slope through point P. You can remember. So this is chapter 2, section 1, number 3. If we have any curve, I call it a circle. Secant is any line that goes through the graph at 2 points. A tangent, so that's secant. A tangent line only touches the graph at 1 point. So what this one's asking us is to find the slope of the curve y equals x squared minus 4x minus 4 at the point 3, negative 7 by finding the secant. Alright, the secant slope simply is the rate of change. But in this one, instead of saying f of x2 minus f of x1 over x2 minus x1, so what this is saying is this. We have a, I'll use the easy one, so we have a line. Here's x1, here's x2. This is f of x1, and this is f of x2. That corresponds to that point. Okay, so this is, we have a right triangle. The distance between x1 to x2 is h. So in other words, if we started from any x1 value, if we started any one x value and added h, we'd end up at x2. So if we solve for h, get rid of x1. So h is x2 minus x1. And x2 is written as x1 by h. This way, so x2 is written as x1 plus h. and the distance between any 2 points is h. So we only deal with one value, x1. So in here, x2 is x1 plus h minus f of x1. x2 minus x1 is h. So that's our secant slope. We have to find the 2 points that way. Since we only have 1 point, this is x1, this is y1. So what we have here is this. What we have to do here is, inside our function, we have to put in place of x plus h. So we have x plus h squared minus 4x, which in place of x I put x plus h minus 4. That's this first part. So this first part looks like this. Here's the minus sign, and the second one is f of x. Well, that's f of x. So it's x squared minus 4x minus 4. But we have to put it in parentheses because that negative sign is going to change all the signs. x2 minus 1, x1 is h, so it's over h. We have to expand this one. So this is x plus h squared is actually x plus h, x plus h. We have to do some FOILing, which gives us x squared plus 2xh plus h squared. So we have x squared plus 2xh plus h squared. Negative times positive is negative. We have to now distribute that and get rid of the parentheses. 4 times x. Negative times positive is negative. 4 times h minus 4. And this negative just changes all the signs inside there because it's negative. It's multiplied by negative 1. So it becomes a negative x squared. Negative and negative makes it a positive 4x. Negative and negative makes it positive 4 over h. Alright, here's a hint. Everything after this minus sign, all these three here, in this case, they have to cancel out. This next step. So this negative x squared cancels that positive. The positive 4x cancels the negative 4x. Positive 4 with the negative 4. So what we have left is 2xh plus h squared minus 4h over h. The numerator we can simplify. We can factor out an h out of each of those. So this first one only has one in it. This one, we take away one of them, and we take away that last one. Which gives us our value, our function, 2x plus h minus 4. So this is the equation of our slope. From f of x1 to f of x1 plus h. So, but those are the 2 points. We can't really find the slope of that. So what we do here is we let the value of h go to 0. Because what that means is the distance between x1 and x2 goes infinitely small. Eventually that disappears. we end up with 2x minus 4. Remember, our point was at 3, negative 7. We use this x value in here. 2 times 3. 2 times 3 is 6, minus 4 equals 2. So that is the slope which I'm looking for. There it is. So find the slope of that point. The slope is 2. Now the next one says find the equation of the tangent line at that point. So 2.1, question number 3, B. The equation of the tangent line, or line tangent to the curve, at remember, to find an equation of a line, you need two things. One, you need a point, which we have. We have 3, negative 7. Next thing you need a slope, which we have it. For the last question, the slope equals 2. Put in the equation. This is our x value, that's our y, and that's m. We don't know our y-intercept yet. So y is negative 7, m is 2, x is 3. Two times 3 is 6. Subtract both sides by 6. B is negative 13. So we have our slope is 2, and our y-intercept is negative 13. Put it back into our equation. The slope is 2. B is negative 13. And there's our equation of the line tangent to the curve. To x minus 13. Right. So that does it in page 1. Now we have the next one. Question number 4. Let's see what this says. The profits of a small company for each of the first 5 years of its operations are given in the table to the right. Plot points representing the profit as a function of years and joining them with a smooth curve as you can. Alright, let's look at these. At 2010, these are the x values. Year is always x. Time is always x. And then this is the y values, the profits, or the number of sales. So, in 2010, the profit was 11. This one can't be it. At 2011, it was 32. 32 is not bigger than 50, so this one can't be right. This one might be right, but this one's closer to 75, so it has to be C. That's what the graph's going to look like first. Now, find the average rate of increase of the profits between 2010 and 2011 is what? So at 2010, it was 11. Remember, these are all times 1,000. So it's 11,000. at 2011, the profit was 32,000. So the average rate of change. Average rate of change, this is for question B. This is difference of y over difference of x. F of x2 minus f of x1, x2 minus x1. So these two are points. The first point is 2010, 11, and the second point is 2011, 32. So this is x1, this is x2. y1, y2. So f of x2 is 32, f of x1 is 11, x2 is 2011 minus 2010. 32 minus 11, 21. 2011 minus 2010 is 1. So it's 21. 21 times 1,000 is 21,000. So that's your answer. $21,000 per year. Now, the rate in which the profit were changing from in 2012. So what we do here, since we're looking at the profits, how they're changing in that, what we do is we take the values of the two terms around it and find the rate of change there. So what we do here is we find 2011, we know that's 32,000, and we find at 2013, that was at 116,000. So here we find the rate of change. So we have f of x2 minus f of x1. This is how we're estimating it. So x2 minus x1. So the y values, 116, that's the f of x2. This is x2, this is x1. F of x2 is the y value, minus f of x1. 2013 minus 2011. 116 minus 32 is 84. 13 minus 11 is 2. So the profits is 42,000. All right, so far so good. All right, so we're at 2.1, question 5. Ooh, my, it's got a lot of steps. All right, let's look at these. The accompanying graph shows the total distance S traveled by bicycle after T hours. So here's the, again, time is always the x-axis. The distance is the y-axis. So which of the following is the bicyclist's average speed in miles per hour over the time interval 0, 1? So what this is looking for is, this is looking for A1. So in the time interval 0, 1, when x is 0, the rate is 0. So this is the x and this is the y. The time, the rate, the distance. So it didn't go anywhere at 0 time. When x is 1, goes to 12. So this is x1, x2, f of x1, f of x2, the y values. So we have f of x2 minus f of x1, x2 minus x1, 12 minus 0, 1 minus 0. So the answer is B. Do something for A2. In the interval 1 and 2.5. So when at 1, we know it's 12 from above. At 2.5, we go to 24. Now, this is x1, this is x2, this is f of x1, this is f of x2. So f of x2 minus f of x1, x2 minus x1. So we have 24 minus 12, 2.5 minus 1. So it's 12. 2.5 minus 1 is 1.5. That equals positive 8. So the answer is D, 8. Now let's look at the third one. The third one says intervals 2.5 and 3.5. So A3, the interval is 2.5 to 3.5. So at 2.5 and at 3.5. So at 2.5, we have 24. And at 3.5, we have 28. At 3.5, we have 28. Same formula to f2 minus f1, so it's 28 minus 24, 3.5 minus 2.5, 28 minus is 4. 3.5 minus 2.5 is 1. It's 4 miles per hour. Now, this other one, the next one. Now it changes. We're looking for the instantaneous speed. Where's B? There's B. Alright. We're looking for it now, instantaneous speed at t equals 1/2 hours. All right. What we have to do here is, since we're looking at 1/2, we have to look at 1/2. We have to look at the values of both. What happens at 0 and what happens at 1. Look at both sides. So at 0, it's 0. At 1, it's 12. basically we're looking at what's the average of those. So remember, this is the f of x, this is the x. So we have f of x2 minus f of x1. So the instantaneous rate of change at half an hour is 12, B. So otherwise, if we had the function to find the instantaneous rate of change, it would be the limit as h goes to 0. So that would be the instantaneous rate of change. We would look at h going to 0, but we don't have the function. So what we're doing is we're going to approximate between two numbers on both sides. Alright, now we're looking at 2 hours. So that's B1. This is B2. At t equals 2 hours. So what happens here? So let's look at the two values of 1.5 and 2.5. These are our x's. These are our y's. So at 1.5, it's 22. And 1.5 again. And at 2.5, let's look at our function. But at 2 hours, if we notice here, the average rate of change, the slope is horizontal. So all along here, the average rate of change is 0. So in this case, we don't have to do anything. We know that the instantaneous rate of change at 2 hours is 0. And at 3. This instantaneous range, remember, it's the slope. It's 0 because it's flat. Now at the third one, we're looking at 3 hours. So let's look at 2.5 and 3.5. This is the x. This is the y, or the f of x. At 2.5, we have 24. At 3.5, we have 28. So 28 minus 24 over 3.5 minus 2.5, 4 over 1 is 4. So the answer is D. Okay. Now C. Which of the following choices gives the maximum speed in miles per hour at the time in which it occurs? First one, when t is 1, 24 miles an hour. Okay. At 1 hour, it's 49. No. Okay, I'll show you how we're going to do this. So at 1 hour, between 0 and 2, we have 24. So it's an increase. So that's a possible one. This one's out of the range because the whole graph doesn't go higher than 40, so that one can't be right. This one can't be right. And at 3.5, it's above 24, so that one can't be right. So it has to be A. It has to be plausible. Okay, number 6. Find the average rate of change. Give the interval, so this is x1, this is x2. So f of x1 equals f of 4 squared, 5 times 4, 16 plus 20, 36. F of x2. So it's at 7. 7 squared plus 5 times 7. 49 plus 35. 84. So the average rate of change, remember it's dy over dx. So it's 84 minus 36. 7 minus 4. 84 minus 36. 48. 7 minus 4 is 3. 3 goes into 4 once, with 1 left over. 3 goes into 18, 6. B. Same thing here now. F of x1, this is x1, this is x2, so f of 5. Negative 3 times 5 squared minus 5. 3 times 25 minus 5. Negative 75 minus 5 equals negative 80. F of x2, which is f of 6. Negative 3 times 6 squared minus 6. 3 times 36 minus 6. 3 times 36 is negative 108 minus 8, so it's negative 114. Remember, it's f of x2 minus f of x1, x2 minus x1. So, negative 114 minus a negative 80. 6 minus 5. Those negative signs become a plus. Negative 114 plus 80 is 34. 6 minus 5 is 1. The answer is negative 34. D. Now number 8. Use the slopes of UQ, UR, US, and UT to estimate the rate of change at x equals 5. So what we're going to do is we're going to use these secant lines, the slopes of these secant lines, to estimate the tangent line, the slope of the tangent line. So let's first see these. UQ. Maybe first, the point U is at 5, 5. The point T is at 4, 3.25. That's an approximate. The point S is at 3, 1.75. The point R is at 2.75. And the point Q is at 0.25. So the first thing is UQ. So we're looking at the points 5, 5, 1, 0.25. We're going to be using this equation on all of these. So this is x1 f of x1, x2 f of x2. Because, okay, this is our first point, that's our second point, so. So we have 5 minus 0.25, 5 minus 1, actually it'd be easier if I put 2, 0 here. Because if I use 2, 5, then I might have some weird number. 5 minus is 4.8 over 4, 1.2. It's an approximation anyway. The next one I gotta look at is UR. So this is U, and R is 0.75. So 5 minus 0.75, 5 minus 2. 4.25 over 3. There's 1 left over. 1.4 ish. Okay, so the next is US. So it's 5, 5. S was 3, 1 point. Let's make it 0.8. Make it easier for us. So it's 5 minus 1.8. 5 minus 3. 5 minus 1.8 is 3.2 over 2. 2 goes into 3 once. 2 goes into 12, 6. Next I go to u to t. Yeah, that's u and that's s. So u is 5, 5. For 3.25. That's u and that's t. So it's 5 minus 3.25 over 5 minus 4. 1 point. Well, I think it. Oh, so it's 1.8 over 1, which is 1.8. Make it 0. So we see it's getting close to a certain number. The closer we get to 5, so we're going to estimate it's 2. The rate of change we're going to estimate is 2. So it's A. So that's the numbers 1.2, 1.4, 1.6, 1.8. So it's getting close to that number 2. Alright, that does it for section 1. Alright, good luck everybody.